Now there are two very important and simple theorems in limits, which are Cauchy theorems on limits. Now the first theorem says, if limit an equals to a and bn is average of all these ai's, then limit of b is same as limit of a. And the second theorem says, if an is a positive number, then for all n, this limit n tends to infinite an to the power 1 by n will be same as this limit n tends to infinite an plus 1 upon an. Now we generally use these theorems to simplify problems in limits. Let us take up an example. Say for example, the question is, show that this limit n tends to infinite 1 upon under root n square plus 1 upon under root n square plus 2 up to 1 upon under root n square plus n, and this is equal to 1. Now generally we solve this question using sandwich theorem or squeeze play theorem. Now here we are going to solve this question using Cauchy's theorem on limits. So what we'll do is we'll write this as limit n tends to infinite 1 by n upon under root of n square plus 1 plus n upon under root of n square plus 2 up to n upon under root of n square plus n. Now this limit is of the form limit n tends to infinite 1 by n a1 plus a2 plus an. Now Cauchy's first theorem says this limit, it is equal to this limit n tends to infinite an. So all we need to do is we need to solve this limit n tends to infinite. Now what's an? An is n upon under root of n square plus n, and this limit is nothing but 1. So value of this limit is simply 1. Now here the question is, we need to show that this limit 1 by n, 1 plus 2 to the power 1 by 2, 3 to the power 1 by 3 plus n to the power 1 by n is equal to 1. Now using Cauchy's theorem, we can say that this limit, which is 1 by n a1 plus a2 plus a3 plus an, is equal to limit n tends to infinite an, and an in this case is n to the power 1 by n. Now we can write this as limit n tends to infinite e to the power log n to the power 1 by n. So it will be e to the power this limit n tends to infinite log n by n. Now this is log infinite upon infinite, so it is infinity upon infinity form. We can use L'Hopital's rule. We can write e to the power this limit n tends to infinite, and it will be 1 by n upon 1. So it will be simply e to the power 0, which is 1. So the value of this limit is nothing but 1. Now here the question is, evaluate this limit. Now we'll take this as y, and if we take log, we can write log y equals limit n tends to infinite 1 by n log 2 upon 1 plus log 3 upon 2 square plus log n plus 1 upon n whole to the power n. Now we'll use Cauchy's first theorem. We can write log y equals this limit n tends to infinite an, and an in this case is log n plus 1 upon n whole to the power n. Now this is log y, and it will be this log, and this is standard limit 1 plus 1 by n to the power n when n tends to infinite, and this is nothing but e. Log e is 1. If we take anti-log, value of y is simply e. So value of this limit is nothing but e.